Hi everyone, today we are going to give a name to that angle that was located inside of the triangles that we created in our last lesson. So in our last lesson, we always wanted to identify the sine of theta, cosine of theta, tangent of theta, and we used this other angle and we just so happened to call it theta. So now we're going to give it an actual name and describe our bow tie angles that we talked about in the last lesson. Those angles are what we call reference angles. Before we get started, I would like you to please go ahead and complete this really quick warm-up. I want you to identify the arc length and the area of a sector, given that the radius of that sector is 10 inches and the measure of the central angle of that sector is 150 degrees. Please pause the video, identify the length and the area, restart the video, and we'll see how well you did. Okay, so for our formulas for finding the arc length and the area, we know that arc length is S is equal to R times theta, and we know that the area of the sector is A is equal to 1/2 R squared times theta. Now, theta cannot be in degrees, it has to be in radians. So hopefully by now you recognize that 150 degrees is one of our special angles, and a special angle that we need to study for our unit circle. 150 degrees, look at the 15. 15 is divisible by 3, and because it's divisible by 3 and not 6, that means it's part of our 30-degree angles. So that tells me that it's going to be something over 6, some pi over 6. So one thing I want you guys to get in the habit of is memorizing your unit circle and making sure that you can recognize what type of angle you're talking about. So 150 degrees, I know that that is going to be located in the second quadrant, and it's 30 degrees away from 180, which is pi, and I know that at this location, I know that my denominator is 6, and going with my little trick that I found that we talked about in the last couple of days, I'm going to take my denominator and subtract 1, and I'll have my numerator. That's going to be 5 pi over 6. So 5 pi over 6 is going to be my theta. So I'm going to write 5 pi over 6. If that is too confusing, then I want you to go back to that formula where you can go 150 times pi divided by 180. The degrees would cancel out. We'll be left with radians. And we have 150 pi over 180. And that simplifies once again to 5 pi's over 6. So both approaches will get you your theta. So that's the value that we're going to use. So I'm going to write that my arc length is equal to 10 times 5 pi over 6. So that's going to be equal to 50 pi over 6 if I were to multiply straight across. And 50 divided by 6 simplifies to 25 pi divided by 6, and my length is in inches. So that is going to be 25 pi over 6 inches. For my area, I'm going to write 1/2 times my radius squared, so that's going to be 10 squared, times 5 pi over 6. So I'm going to multiply straight across, so this is going to be A is equal to 10 squared is 100, 100 times 5 is 500 pi, divided by 2 times 6, which is 12. And 500 pi divided by 12, that simplifies to 125 pi over 3 inches squared, and so that is our area. So hopefully you have your area and arc length formulas memorized. That's going to be something that's very important. I need these to be considered your easy questions. So let's go ahead and look at our learning targets. Our learning targets for today is for you to be able to say, I can identify and sketch the reference angle for any angle in degrees as well as in radians. And I want you to be able to tell me or be able to identify the sign, whether or not it is positive or negative. So I want you to be able to identify the sign, whether it's positive or negative, of trigonometric functions given a quadrant of the terminal side of an angle. So what that means is I'm going to give you like the cosecant of 300 degrees. I want you to be able to tell me what that value is going to be. And then I want you to be able to evaluate, I can evaluate trigonometric functions for any angle without a calculator. So all of the work that we're going to be working with today is going to be without a calculator. So reference angle. We had bow tie angles that we talked about in our last lesson. They were created with the origin and the x-axis. So we had ourselves bow tie angles. And all of these bow tie angles are angles that are created with the x-axis and the origin. So what I'm drawing right here, the little arcs, those are all of your reference angles. What we're talking about is the distance that an angle is away from the x-axis. So that is what a reference angle is. The distance in degrees or in radians that an angle is away from the x-axis. So it's always based on the x-axis. So we have reference angle. The reference angle for theta is the acute. So these are always going to be acute angles. And on top of that, they're always going to be positive as well because we're talking about a distance. So it's always positive. So the reference angle for any angle is the acute angle that we call theta prime, formed by the terminal side of theta and the x-axis. So your bow tie angles. Reference angles relate the given angle to its corresponding angle in the first quadrant. So every single angle is going to correspond to something in the first quadrant. So I've said to a lot of people, know your first quadrant, and if you know your first quadrant, you can do anything. So if we were to look at 150 degrees, 150 degrees falls into a family. We have ourselves 4 different families. We have the 30-degree family, the 45-degree family, the 60-degree family, and the 90-degree family. All of our angles are going to fall into one of those categories. Likewise, we have ourselves the pi over 6 family, the pi over 4 family, and the pi over 3 family, as well as the pi over 2 family. So we have a lot of different families that I need you guys to please make sure that you know and study. So please note that if we're talking about degrees, our answer is going to be in degrees. And all reference angles in degrees, so we're going to call that theta prime, is going to be in between 0 and 90 degrees. Notice that it is not inclusive. So if we're talking about 0 degrees or 90 degrees, we're no longer talking about an acute angle, no longer talking about a reference angle. So please just keep that in mind. Also, if we're talking about an angle that is in radian measure, our reference angle is going to be in between 0 pi and pi over 2. And that's because 90 degrees matches up with pi over 2 and 0 degrees matches up with 0 pi. So that's where it's going to be located. Now, the direction of a reference angle, it doesn't matter. You're just asking yourself, how far away is that angle away from the x-axis? So I keep on saying that over and over again, so I want to make sure that I write that down. A reference angle is the distance an angle is, or an angle's terminal side is away from the x-axis. So I cannot stress that enough. It's how far away is your angle from the x-axis. Do you have to travel backwards? Do you have to travel forwards? Direction does not matter whenever we're talking about reference angles. So it says, let theta be an angle in standard position. The reference angle for theta is the acute angle that we call theta prime, formed by the terminal side of theta and the x-axis. The relationship between theta and theta prime is shown below for non-quadrantal angles of theta, such that 90 degrees is less than theta, which is less than 360, or pi over 2 is less than theta, which is less than 2 pi. What this is talking about is that every angle that is located in the second quadrant, third quadrant, and fourth quadrant will have its own reference angle. And what we're also saying is that any angle that's located in the first quadrant is going to be a reference angle to itself. So we're talking about in quadrant 2, we have ourselves theta, we have ourselves an angle. Our reference angle is how far away that angle is away from 180 degrees. So we have to ask ourselves, how big is this piece? So there exist formulas. In order for us to identify that, you would take 180, and since it's before 180, you would go 180 minus whatever your theta value is, whatever your angle value is. And that's going to equal your reference angle. In quadrant 2, notice that your reference angle is going to be located just a little bit beyond 180 degrees. And so since it's located beyond 180 degrees, you're going to take your actual angle and subtract away 180. Or ask yourself how many degrees past 180 you traveled. So that's something to consider. How far did you travel further? And then in quadrant 4, you have to ask yourself, how many more degrees do you need to travel before you reach the x-axis? Now, there does exist all of these formulas down here. They're kind of helpful if you're talking about degrees or if you're talking about radians to tell you where your answer is supposed to be located. However, I don't want you to memorize these formulas. Instead, I just want you to think. So I'm going to literally tell you, please do not memorize these formulas. I want you to just think about how far the angle is away from the x-axis. That is the most important thing. How far away is this angle from the x-axis? I wrote that down in a couple of different ways twice now because I cannot stress that enough. It doesn't matter if the angle that's given to you is negative or if that angle that's given to you is positive. You want to figure out how far away is that angle from the x-axis. And if your angle that's given to you is negative, your reference angle will still be positive because a reference angle is always positive because we are talking about distance that an angle is away from the x-axis. So let's go ahead and look at how to find the reference angle for all of these given angles. So what we have here is theta is equal to negative 165. So I'm going to graph 165. Now notice that this is negative 165, so I'm going to label using negative degrees going all the way around the circle. So negative 165. Negative 165 is going to be located, here's my terminal side, or my initial side, and it's going to be located about 15 degrees away from 180. So this is negative 165 degrees. So we're asking ourselves, how many more degrees do you have to travel before you reach, the x-axis? Well, you have to ask yourself, okay, how many more would I need to travel? So we would take 180 and subtract away 165, and what we're left with is 15 degrees. So if we were to travel 15 degrees more, we would end up at our x-axis. That's how many more degrees we are going to travel before we reach the x-axis. So our reference angle in this case is 15 degrees. Let's go ahead and look at letter B. For letter B, we have 7 pi's over 4. So if I were to draw this angle, 7 pi's over 4, so that's almost 8 pi's over 4. These are one of our special ones that we need to know. So that's going to be located in quadrant 4. So I'm going to do 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So this is almost 2 pi, and it's located at 7 pi over 4. So I'm going to go around, and that's about halfway. And since our answer is in radians, my final answer is going to be in radians. And what's really nice about radians is that your denominator tells you your answer. You have to travel pi over 4 more in order for you to reach the x-axis. So I absolutely love radian measure for that. My reference angle is simply the denominator. It's going to be pi over 4. Done. There is nothing further for you to do. Try not to overthink it. How many more radians do you need to travel before you reach 8 pi? I just need 1 more pi over 4. That's what you're saying to yourself. And whatever your denominator is, that's going to be your reference angle. So that's going to tell you the type of reference angle that you're going to have. In this case, it's pi over 4. Letter C, we have ourselves 150 degrees. And 150 degrees is one of our special angles that we need to know. 15 is divisible by 3, so that means, and it's not divisible by 6, so that means that it falls into our 30-degree family. So because it falls into that 30-degree family, 30 degrees is going to be my reference angle. Think about this. I'm going to draw my picture of 150 degrees. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. How many more degrees do I need to travel before I reach 180? Well, that is going to be 30 degrees. So my reference angle is going to equal 30 degrees. That's how many more degrees I have to travel before I reach the x-axis. So you might want to put your degrees into categories if you can, especially if you're given something that is special. Now, if you're not given something that is special, like 165, then that's where maybe these little rules might come in handy. But I think that just using logic might be even more beneficial. How many more degrees do you need to travel before you reach your destination, which is the x-axis? Let's go ahead and look at letter D. For letter D, I'm going to graph 5 pi's over 3. 5 pi's over 3, once again, is one of our special angles that we need to know. It's almost 6 pi's over 3, so that means it's going to be located in the third quadrant. So I'm going to draw, the fourth quadrant. So here's my 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And here is 5 pi's over 3. How many more do you have to travel? Well, this is why I love radian measure, because that 3 in the denominator tells you how much further you need to go. I need to travel pi over 3 more before I reach the x-axis. If I were to travel pi over 3 more, I would have 5 pi over 3 plus a pi over 3, which will give me 6 pi over 3, and that is 2 pi. So my reference angle is pi over 3. So once again, you might want to put your angles and your radians into categories, because those categories will tell you what your reference angles are. And your reference angles will save you a lot of time whenever you are evaluating different angles, if I'm asking you what the sine of 45 degrees is or anything like that, you can identify that angle or that value very, very quickly just by using your reference angles. Let's go ahead and flip the page. So I just talked about evaluating trigonometric functions. So when it comes to evaluating trigonometric functions, we learned when we were studying the unit circle that all students take calculus. That was our little phrase that we worked with. All students take calculus. And what that represented is it represented the signs of all of our values, represented all of the signs of our values that are positive. So in the first quadrant, in quadrant 1, both sine and cosine, and then tangent were all positive. So in quadrant 1, all are positive, and that's where that A comes in. The S indicates that only sine is positive in quadrant number 2. In quadrant number 3, only tangent is positive. And in quadrant number 4, only cosine is positive. So that what's really nice is that we can use this phrase in order to tell us what our sine of our angle is going to be, and what the sine of our answer is going to be. So whenever you're asked to evaluate the sine, cosine, tangent, cotangent, secant, identify these values, there exist shortcuts. So what I'm talking about these are going to be things that could potentially be at the bottom of your unit circle test. So a shortcut, instead of being so dependent on your unit circle, is to know the quadrant 1. So what I'm going to do is I'm going to draw a quadrant 1. And I'm going to identify all of my angles, all of my ordered pairs, and all of my coordinates. So I'm going to identify my angles both in degree and radians and all of my ordered pairs. So this is 0 pi, 0 degrees. The ordered pair is located at 1, 0. We have 30 degrees, and 30 degrees is pi over 6. That ordered pair is the square root of 3 over 2, 1/2. This is 45 degrees. This is pi over 4, and my ordered pair is square root of 2 over 2, square root of 2 over 2. And for 60 degrees, that's pi over 3. We have ourselves 1/2 square root of 3 over 2. And then up here is 90 degrees, and that ordered pair is going to be located at 0, 1. My tangents are going to be square root of 3 over 3 for 30 degrees, 1, and square root of 3 for 60 degrees. So 1 is for 45 degrees, and square root of 3 is for 60 degrees. If you know this information, you know at least a good solid chunk of your reference angles that we're going to be working with. So let's go ahead and look at step 1. We want to evaluate the trigonometric functions for any angle. The first thing that you want to do is you want to identify your reference angle. What type of angle are you talking about? What category does it fall into? The next thing you want to do is you want to evaluate the trigonometric functions for theta. So you want to identify the ordered pair. So whatever that ordered pair might be. So you want to identify the ordered pair that we're working with. Then the third thing you want to do is you want to determine the sign. Is it located in quadrant 1, 2, 3, or 4? Where is it located? Determine the sign of the trigonometric function value from the quadrant in which theta lies in. So theta is where your actual angle is located. So you might want to draw a picture. And then from there you'll be able to identify what your answer is. So what I mean by that is this. We have ourselves the cosine of 225 degrees. Now, we know that 225 degrees, well, 225, it ends in a 5. This is a special angle. My reference angle is 45 degrees. How do I know that so quickly? Well, 225 degrees is a special angle. It's one of the angles that I need to know. It ends in 5. I know my patterns. I know that any angle that ended in 5 automatically was a reference angle of it has a reference angle of 45 degrees. It falls into that family. What I need to know now is I need to know what quadrant it falls into. So draw a really quick sketch. It doesn't need to be a perfect sketch. We know that this is negative, so I'm going to go clockwise. So I'm going to go backwards. This is going negative 90. This is negative 180. Negative 225, so that's going to be negative 270. So it's going to be in between 180 and 270 and about halfway there. So here's my, let me make sure this is in focus so you can actually see it. How many more degrees do you need to travel before you reach the x-axis? Well, guys, that's 45 degrees. So awesome. I know that that is 45 degrees, and I know that this is located in quadrant number 2, and I want to find the cosine. So now I needed to ask myself, what type of sign does cosine have in quadrant 2? In quadrant 2, only sine is positive, so that tells me that my answer is going to be negative. So the cosine of negative 225 degrees, that's going to be equal to a negative. So now I'm going with negative. Where's my 45 degree angle? So my 45 degree angle, cosine is square root of 2 over 2. My answer is negative square root of 2 over 2, and I am done. There's nothing more for me to do. Let's go ahead and look at the cotangent of 10 pi over 3. So what's really nice about 10 pi over 3 is that I know what my reference angle is right away. I know that it's pi over 3. And I know that at pi over 3, my ordered pair is going to be 1/2 square root of 3 over 2. I'm sorry, I'm going to be working with cotangent, which means that we're working with tangent. And I know that for tangent, my tangent of anything that's a pi over 3 is going to be a square root of 3. So that's what I'm going to be working with. What type of square root of 3 or reciprocal of square root of 3 am I going to be working with? Well, I need to figure out the location of 10 pi over 3. So I'm going to draw a really quick sketch, and we're talking about 10 pi's over 3. So I know that this is 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. So 3 pi's over 2, or I'm sorry, 10 pi's over 3. Well, I know that 3 can go into 10 3 whole times with 1 left over. So that's what I'm going to do. Here is 1 pi, here is 2 pi's, here is 3 pi. So what I did is I know that 10 over 3, that's equal to 3 and a third pi. That's what I did, is I wrote it down as like a whole number with a fraction. So I went 1 pi, 2 pi's, then I'll need to go, so 1 pi, 2 pi, here is 3 pi, and then I need to go a little bit more. So a little bit more is going to be down here into quadrant number 3. So this is quadrant number 3. And this is cotangent, which means it's related to tangent. And I know that the tangent of 10 pi over 3 in quadrant 3 is going to be positive, because in quadrant 3, tangent is positive. So the tangent of 10 pi over 3, that's going to be equal to the square root of 3. And I know that cotangent has to be the reciprocal. So the reciprocal is going to be 1 over the square root of 3. And the reciprocal of 1 over the square root of 3, well, I can't have a root in my bottom, so I'm going to rationalize the denominator. And I find that the cotangent of 10 pi over 3, that's going to be equal to the square root of 3 over 3. And that is my answer. Let's go ahead and look at letter C. For letter C, we have to find the secant of 300 degrees. So the secant of 300 degrees, that is, well, I have to figure out what type of angle it is. So I always look at the first two numbers and I ask myself, is it divisible by 3 or is it divisible by 6? Well, all numbers that are divisible by 6 are also divisible by 3. So I have to ask myself, are the first two numbers divisible by 6? In this case, 30 is divisible by 6. And because it is divisible by 6, that tells me my reference angle is 60 degrees. That is a little trick that we have. So once again, you take the first two numbers and ask yourself, is it divisible by 6? If the answer is yes, it's a 60-degree angle is the reference angle. Secant is the reciprocal of cosine. So my ordered pair for cosine, if I were to look at cosine, that's going to be 1/2 square root of 3 over 2. Cosine is the x value, so I'm going to be working with 1/2. What I need to figure out is my location. What quadrant is 300 degrees located in? Now, we should know 300 degrees is located in quadrant 4. So if you were to draw a really quick sketch, we know that 300 degrees is located in quadrant number 4. And so since it's located in quadrant number 4, I need to decide, is cosine of 300 degrees positive or negative? Well, quadrant number 4, calculus, cosine is positive, so I'm going to be working with the positive 1/2. Now secant is the reciprocal, so the secant of 300 degrees is going to be the reciprocal of 1/2, which is 2. 2 over 1, which is 2, and that is it. That's all your answer is. Please go ahead and try letters D, E, and F on your own. See if you can handle these problems on your own. Draw a picture, draw a sketch. See if you can identify the reference angle. And when you have an answer, please go ahead and restart the video, and we will see how well you did. All right, let's go ahead and look at letter D. So for letter D, we have ourselves the sine of 17 pi over 6. So what's really nice is that we know a reference angle. It's based on our denominator, and our reference angle is going to be pi over 6. Pi over 6 has an ordered pair of square root of 3 over 2, 1/2. So looking at that ordered pair, we have square root of 3 over 2, 1/2, and we want the sine of that angle. So sine is your y value, so I'm going to be working with 1/2. What I need to figure out is what location is 17 pi over 6. So I just need to figure out where that's going to be located. Well, let's go ahead and think about what 17 over 6 is. Well, 6 can go into 17 2 whole times with 5 left over. So this is going to be 2 and 5 pi over 6. So I'm just breaking it down into how far away. If this was 18 over 6, that would be located at 3 pi. But since it's 17 over 6, that means 6 can go into 17 2 whole times with 5 left over. Okay, maybe that'll help us out. So this is going to be 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So I'm going to go around the circle. Here's 2 pi, so that's 1 pi, 2 pi, and now we need to go 5 pi's over 6 more. So 5 pi's over 6 more, that's going to be almost to another pi, but not quite there. So this is located in quadrant number 2. So we have ourselves quadrant 2. And we're talking about sine. So all students take calculus. So that means that sine is positive in quadrant 2. So that means that the sine of 17 pi over 6 is going to be simply equal to a positive 1/2, and there's nothing more that you need to do. Let's go ahead and look at the tangent of negative 240. Well, 24 is divisible by 6, so that tells me automatically that my reference angle is a 60-degree angle. So looking at, and I want tangent, and I know that the tangent of 60 degrees, that's going to be the square root of 3. I just need to figure out what type of square root of 3 my answer is going to be, so I need to figure out where negative 240 is located. So we're working with negative degrees, so we're going in a clockwise motion. Putting in all of my degrees. So I know that negative 240 is located in between 180 and 270. So that means that my angle is going to be located in quadrant number 2. So in quadrant number 2, tangent is not positive. Sine is positive in quadrant number 2. So that tells me that that tells me that the tangent of negative 240 degrees is equal to negative square root of 3. And that is our answer. Let's go ahead and look at letter F. Cosecant is the reciprocal of sine. So I'm going to need to identify, I'm going to be working with our sine function. My denominator is a 4, so that tells me that my reference angle is automatically pi over 4. And so pi over 4, and we're talking about sine of pi over 4, so that means that we're working with the square root of 2 over 2, square root of 2 over 2. Sine is your is the y value, so I'll be working with that, and then I'll be taking the reciprocal. What I need to know is it positive or negative based on the location that it is in the, based on its location. What quadrant is it located in? So this is 0 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So drawing this angle, 4 can go into 15 3 whole times with 3 left over. So that's going to have 3 pi over 4 left over. So I'm going to go around the circle. Here's 1 pi, here's 2 pi, here is 3 pi, and I need to go 3 pi's over 4 more. So that's almost 4 pi's over 4. So 3 pi's over 4. That's going to be located right here in quadrant 1. So my answer is going to be in quadrant 1. Quadrant 1, we know that everything's positive. So that means that the sine of negative 15 pi's over 4 is going to equal a positive square root of 2 over 2. But since we're talking about the reciprocal, the cosecant of negative 15 pi's over 4, that's going to be equal to 2 over the square root of 2. So we'll have to get rid of the root by multiplying the top and the bottom by the square root of 2. So we end up with 2 square roots of 2 over 2. The 2's cancel out, and our answer is simply the square root of 2. And that is it. We have one more example, and then we are finished for today. And it says that the Frogbot is a robot designed for exploring rough terrain on other planets. It can jump at a 45-degree angle with an initial speed of 16 feet per second. On Earth, the horizontal distance, d, so that's the horizontal distance, d, in feet traveled by the projectile launched at an angle of theta with an initial speed of v, which is in feet per second, is given by our formula. D is equal to v squared divided by 32 times the sine of 2 times theta. We want to figure out how far can the Frogbot jump on Earth. Okay, so what we need to do is we need to identify our information that is given to us. So we need to figure out how far can the Frogbot jump. So that is going to be our distance, our horizontal distance in feet. And that's how far it's going to travel. So that's on Earth, the horizontal distance is d. That's what we want to find. Our V represents our velocity, our initial speed. Our initial speed in this case is 16. So I'm going to go 16 squared divided by 32 times the sine of 2 times my angle. My angle in this case is 45 degrees. So that means that I need to simplify this. I would strongly recommend that you work with your fraction individually and you work with your degrees individually. So 16 squared is 256. And that's going to be divided by 32, and we're going to multiply it by the sine of 2 times 45, which is 90 degrees. The sine of 90 degrees, well, let's think about this. Sine of 90 degrees, the ordered pair for 90 degrees is 0, 1, and sine is your y value. So the sine of 90 degrees is 1. So this is 256 divided by 32 times 1. And if anything times 1 is just itself, and 256 divided by 32, that is equal to 8 feet. And that is your answer. That's how far the frog bot can jump on Earth. There's going to be a question very similar to something like this on your test, so I want to make sure that you guys pay attention to it. That is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.